students, welcome back to Algebra 2. Today we're going to talk about the quadratic formula. Now this was a staple of Algebra 1, so hopefully this is a review for you. We are going to mix in some irrational numbers and some complex solutions into this. We'll go a little bit deeper than Algebra 1, but in general this should be a review. So remember that in order to use the quadratic formula we need to start off with a trinomial in standard form. So we say if ax squared plus bx plus c is equal to 0. So again, we have a quadratic equation in standard form that's equal to 0. All of these things have to be true before we're allowed to use the quadratic formula. Then we can say that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this formula can seem a little bit intimidating to people at first, and I do want to show you that this formula wasn't just made up. We solved the equation and then found that this was the formula that goes with it. The way that we solve this, I can demonstrate this, is what if I just took the equation ax squared plus bx plus c is equal to 0. What if I took that and just solved for x, tried to get x by itself? Well, the way I would solve this quadratic is first, I don't like the fact that it's got a leading coefficient, so I'm going to divide everything by a. So I would get x squared plus b over ax plus c over a is equal to 0. Now I'm going to go ahead and complete the square on this, which means I'm going to get rid of this c over a first. So I'll have x squared plus b over ax equals negative c over a. Now, in order to complete the square here, I would have to cut b over a in half and then square it. So I'm just going to do some work off to the side here. B over a cut in half would be b over 2a. But then if I squared it, I would get b squared over 4a squared. So that means that I would say x squared plus b over a x, and then I would add b squared over 4a squared is equal to b squared over 4a squared minus c over a. Okay, so remember that completing the square, the whole point of it is that it ends up factoring into a perfect square. So this would be x plus b over 2a squared, and that would be equal to, now let's go ahead and simplify this side here. I've got a fraction minus another fraction, so that means I need to make them common denominators before I move forward. So this one's 4a squared. In order to turn a into 4a squared, I would multiply it by another 4a. So that would mean this piece right here turns into b squared over 4a squared minus 4 times a times c over 4a squared. Putting them together, I would get b squared minus 4ac over 4a squared. Now, in order to solve this now, I would want to get rid of that squared on my binomial right there. In order to get rid of squared, I would square root both sides, leaving me with x plus b over 2a is equal to, anytime I take the square root of something, I get a positive or negative answer. Square root of b squared minus 4ac over 4a squared. Now, I don't know what the square root of b squared minus 4ac is, but 4a squared can be square rooted pretty easily, so I remember that with square rooted fractions, I can do the numerator and the denominator separately. So I get b squared minus 4ac over square root of 4 is 2, square root of a squared is a. So now I get x plus b over 2a is equal to plus or minus b squared minus 4ac over 2a. Well, in order to get the x by itself, I just need to subtract b over 2a from both sides. So I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And hey, look, those have common denominators. So that means I can put them together to get x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And that is how the quadratic formula was found. Now, all that to say, how do we use it? Okay, so we're going to solve x squared plus 3x equals 5 using the quadratic formula. So I'm going to go ahead and subtract 5 from both sides. So that way I can have x squared plus 3x minus 5 is equal to 0. In this case, I need to identify a, b, and c. So I see a is 1, b is 3, and c is negative 5. So now I can go ahead and start plugging that into my formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in the values, x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5 over 2 times 1. Now, before I go ahead and simplify this is worth mentioning. There's some questions on the homework about this. This piece right here inside the square root, this is called the discriminant. Now, the reason we call it the discriminant is because we treat the problem differently based on the results of the discriminant. So I have a square root right there. So if I have the square root of a positive, if all of these numbers on the inside end up being positive, that means that my equation has 2 real solutions. If I have the square root and everything on the inside of the discriminant turns into a 0, that means I have 1 real solution. And then if I have the square root and I have a negative on the inside, that implies that there are 2 complex solutions. So as we move forward, this is something to keep in mind. So if I simplify the discriminant here, I'm just going to remove this from the problem, and then we'll put it back later. 3 squared is 9, minus 4 times 1 times negative 5 would be minus negative 20. So that would be negative 9 minus negative 20 would be the square root of 29. Now that's a positive number, so that means we have 2 real solutions. So plugging that back in where it was, I would get negative 3 plus or minus the square root of 29 over 2. Now, right there, that is my 2 real solutions right there. So a lot of the time, since the square root of 29 is an irrational number, a lot of the time we can just stop there. However, if we want to go further into decimal approximations, what I can do is go ahead and just calculate what's the square root of 29. Well, it's 5.39. So we would say that this is negative 3 plus 5.39 over 2, or negative 3 minus 5.39 over 2. And then we can just calculate this. Negative 3 plus 5.39 divided by 2 is equal to 1.195. So I can say x equals 1.195. Or I can go through here. I'm just going to change that to a subtraction. Or x is equal to negative 4.195. So now we can put that into bracket notation. X equals squiggly bracket 1.195, negative 4.195, squiggly bracket.